Penicillin and other general antibiotics are often taken for granted in today's society. Many people do not realize their grandparents could quite possibly remember a time when serious bacterial infection was often synonymous with amputation or even death. In September of 1928, a young researcher named Alexander Fleming noticed an odd pattern in a bacterial culture which had been contaminated by the mold Penicillium notatum. The cultures which were close to the mold colonies appeared to be dissolving away. Fleming realized the mold possibly contained an agent which had antimicrobial properties, and set about trying to isolate this agent, which he dubbed penicillin. This search consumed his studies for the next year and a half, but attempts to purify the agent proved fruitless, and Fleming was not able to perform even animal trials. Penicillin faded into the woodwork until 1935, when 37-year-old Howard Florey took a position as professor of pathology at Oxford University, a position which led to his discovery of Fleming's paper on the antibacterial properties of Penicillium notatum in 1938. By 1940, with the help of biochemist Norman Heatley, Florey's team was able to isolate and test penicillin, and human trials were able to begin by 1941. In a 5-person test group, penicillin proved to be 100% effective in curing previously incurable bacterial infection. The wonder drug of the century had been discovered, earning Fleming, Florey, and Heatley the Nobel Prize in Medicine and Physiology in 1945. However, despite the incredible effectiveness of penicillin in treating bacterial infection, it wasn't until Andrew Moyer's work on mold nutrition paved the way for mass production of the drug that penicillin became available in quantity to the general population. In 1940, penicillin was so rare as to be nearly priceless. The Moyer method of production was able to reduce the price to $20 a dose by 1943. By the end of World War II, penicillin cost only 55 cents per dose. This molecule is penicillin G, the natural derivative of the Penicillium notatum mold. It is characterized by this ethyl phenyl reactive group here. This group makes penicillin able to bond to gram-positive bacteria, or bacteria that have a thick cellular membrane rather than a rigid cell wall. The structure of penicillin closely resembles the structure of a polypeptide backbone in a gram-positive cell capsule. This allows for penicillin to disrupt the production of regulatory enzymes in the cell capsule. The enzymes which are disrupted are responsible for maintaining the flow of water across the cell membrane. When penicillin disrupts the proper functioning of these enzymes, the bacteria is no longer able to balance the flow of water across its membrane. The cell becomes flooded with water, eventually leading to lysis, or cell death. Today, penicillin has been largely replaced. Its key functions have been chemically established, and more effective general antibiotics, such as amoxicillin and cephridine, are in wide use. However, even today it is important not to forget the role that penicillin plays in human health and well-being, and it is important to remember the contributions of those scientists who, in a time of propaganda and nuclear physics, made such a great leap forward in the science of healing.